Hello, my name is Daniel Arazo. This is my video 3 assignment for the ME 210 course, titled Ball Bounce Comparison Test. This video assignment and overall test is actually covering the topic of Chapter 14 found in the Engineering Dynamics textbook. Content. So during this video for assignment 3, we're going to look at the real-life example problem that relates to Chapter 14 in the textbook as well as the problem's information. Alongside that, we'll understand about key concepts that actually relate the real-life problem to Chapter 14 itself. And finally, we'll look at key equations that will be needed to be used in order to solve that problem to find the final answer. When it comes to real-life example of this problem and its backstory, we can use the example of possibly two friends trying to set up a game of dodgeball. However, to do that, they're trying to find softer balls to prevent anybody from getting hurt. However, to find a way to test which ball is softer, they decide to do a drop test with different balls. In this case problem, we can see how these friends actually do the drop test on two different types of balls. We can see the real life example right here. This is a short video showing the ball drop test of ball A, showing that its initial rest being dropped, hitting the ground, and then bouncing back up. The same test was done on ball B, showing how, once again, both ball A and B were dropped from the same height, and the video shows them being dropped, hitting the ground, and bouncing back up. It's shown in this video we have a list of different givens assumed, such as the mass of both balls A and B, as well as we can assume many things such as it starts from rest, or that there be no air resistance or external forces besides gravity. We know that gravity is in fact present as a value of 9.81 meters per second squared. We know that both balls A and B were dropped at the same height, which is 1 meter high, and we can see that balls were actually treated as particles. We can also assume that the floor is fixed and rigid, and we are actually given the measurements of actually that the ball's rebound, or in other words, rebounce height, are actually already given to us, with ball A bouncing up 0.46 meters high and ball B bouncing back up 0.4 meters high. Here are some different photos of the stage of the ball falling down. On the left side, it shows what each photo actually means. The top three photos represent the different stages of the ball falling, ball A, and the bottom three represent ball B. So on the leftmost side, it's actually showing the ball before it's actually being dropped at its original state. The photo 2 actually shows the bounce back moment when after the ball hits the ground, it bounces back up a certain height. And the third image actually shows when the ball actually hits the ground after falling 1 meter. The same goes for the pictures for ball B, where it initially starts at its max height. Second photo shows which height it bounces back up, and the third and final photo shows when the ball actually hits the ground at the moment of impact. Right here, just free body diagram showing the same thing, where initially the ball starts on top with one force going on it, which is weight. After it hits the ground, it's both the weight and normal force that's acting on it. And then when it's actually back in the air after bouncing, we see how it's both the weight and normal force acting on it. Although both A and B had different masses, this overall same trend and journey of the ball going down and back up is overall the same for both balls. The key concepts that are actually shown in this problem is that the concept of kinetic energy, gravitational potential energy, conservative forces, non-conservative forces, and overall the principle of work and energy. In order to determine which ball actually loses more force and energy after its bounce back, we use these equations. The equations of gravitational potential energy, work of non-conservative forces, and obviously kinetic energy as well. Using these equations and understanding the key concepts of Chapter 14, we can find out overall which ball loses more energy after it bounces up, which helps us determine which ball is softer than the other.